Okay, so this video is going to have a look all about differentiating functions involving e. So if we remember from what we've done in the classroom, if we have y is equal to e to the x, e is a very special number that is defined by a number which, when raised to any power, when differentiated, gives itself exactly the same curve. So here's e to the x going through the point 0, 1. And wherever I am on this curve, doesn't matter where I am on, the gradient at any point will be equal to the actual point itself. So when we move along the curve, we end up getting the gradient function. So this means that dy by dx is actually e to the x. That's how e is actually defined. That is the definition of e. It's this special base that has this property. Okay, so now that means we can differentiate any function of e. Now we've got this fantastic property of being able to differentiate e to the x. Let me show you an example. So an example might be, I've now got y is equal to e to the 2x. Now the chain rule says, if I'm going to differentiate something, you differentiate the function and then times by the differential of the part that's inside the function. Let me show you by substitution. So let's let t be equal to 2x. T dashed is therefore equal to 2. Y is equal to e to the t. So dy by dt is just e to the t because it doesn't change. And I've done dt. dt by dx is equal to 2. Therefore, dy by dx will be dy by dt times dt by dx, because it's like these dt's cancel. So this will give me e to the t multiplied by 2. So it gives me 2e to the t. Okay, let's apply this to something a little bit more complicated. I want to differentiate this time with respect to t, and I need to put the function that I'm going to differentiate up here in brackets. So I'm going to do e to the 2t cubed plus 3t. So it's just like having a function defined in terms of x, but this time it's defined in terms of t. So I'm going to apply my chain rule. So if I differentiate that with respect to t, I will get, now remember, e to any function when you differentiate it is just the e to any function. So I can write that in as so. But now I need to multiply by this part here, differentiated. So that gives me 2t cubed becomes 6t squared. 3t differentiated becomes plus 3. And I just need a little bracket there so that everything is being multiplied by the e. And I have differentiated using the chain rule. Now I'm going to try something with x. So I'm going to do d by dx of e to the root x. Now, as we would have done at C1, C2, I'm going to rewrite that into d by dx of e to the x to the half, because I can't really differentiate root x very easily. Let's have a look at what this will be. Okay, so this will be the same as, well, if I differentiate any e to the anything, I get e to the whatever it was originally. That doesn't stay the same. And now I need to multiply by the differential of my function up here. I've got a function inside a function. If I differentiate x to the half, my power comes forward and I get a half. I've got x. And now I need to reduce my power by 1, giving me a half minus a half x. Half take away half is minus a half. Now the only thing I might be asked to do, expected to do here to give me my final answer, is just to tidy this up a little bit. Now this is a negative power, so I can sort this out a little bit and put it all over my 2 x to the half underneath, but that's just root x. So I've got 2 root x, and that's that part. And then sat on the top, I've got my e to the x, and instead of writing a half, I can write root x. Job done. There you go, I'm having fun now. Okay, let's have a go at one more. Now I'm going to differentiate with respect to x 1 over 2e to the minus u squared. So pause this and have a go and then see if you get it right. Okay, well, I'm going to first of all rewrite this as something I can actually differentiate, because I really can't differentiate that in its current form. Now let's have a look. We've got a half, so that's still a half. So we'll leave that alone as a half. And now I've got e to the minus u squared. Well, any negative indice just means the inverse of it, if you like, the reciprocal of it. So we need to bring that up to the top. So that will give me 1/2 times e to the u squared. So it's already looking a lot better. And the reason we can do this, if you like, is because this is just a half times e to the minus u squared. And then I can just sort of split it up into 2 fractions and multiply it, which is what I've done going up to here. Okay, so now I can differentiate it using my chain rule. So my chain rule says differentiate the function first of all, and then differentiate the function that's inside the function. Now remember, this half, if we think back to, oh, that wasn't a very good arrow, but if we think back to C2, that can just come outside. That's just a constant. So this just gives me 1/2 left alone, and now I need to differentiate this thing. So e to the u squared will just be e to the u squared. I'm going to write it over here. But I need to multiply by the differential of the function inside the function. So that's u squared. So that's going to give me 2u. Now my 2's will cancel, and I'll just get an answer of u e to the u squared. Fabulous. Let's just try one more. Right, let's try a sort of polynomial expression involving e. So let's have e to the 2x plus 3e to the minus x. So pause the video and have a go, see how you do. Okay, let's see how we differentiate this guy then. So y differentiated with respect to x. So let's have a look at the first function. So e to the 2x, we'll differentiate that. I'm going to get e to the 2x, but then I need to multiply by my function that's inside my function. So that will give me 2x differentiated, just gives me 2. So that's that term done. Now I need to concentrate on this term. So this term says, leave the e to the minus x alone because that won't change. But I need to multiply by the differential of my function inside my function. So that's going to be -1. So that'll be a minus. And my 3, well, it just sort of stays there. It doesn't affect everything. This is being multiplied by 3. So it comes outside the differential. So I just get that. Now my answer in a mark scheme might not look quite like that. So let's just do a little bit of manipulation. If we put this all over e to the x, then that is exactly the same as what I've got going on here. Okay, e to the minus x is just e to the x. So now this bit on the right hand side will just become -3 because I'm not doing anything to that. I've just written it in a different form. And I need to have a look at my first fraction. Well, I've got a 2 on the top. And if we have a look at my powers, I need to raise this term to whatever power it needs to be so that when I divide it by e to the x, I still get e to the 2x. So that's going to be e to the 3x, isn't it? Subtract my powers, 3x take away x gives me the 2x. So those are equivalent. And actually that's more likely to be the answer that the examiners are going to want to see because I've combined everything, made it more simple, it's prettier. That's what they're going to want to see. Right, that's the end of this video, folks. That's how to differentiate e and any function of e. We're now going to move on to logarithms and how you differentiate logs.